Hello friends, I welcome you in lecture number 3 on vector calculus. In this lecture we are going to discuss about curl of a vector field. We have discussed about divergence of a vector field. If we recall, if f bar is a vector field, then divergence of vector field f bar is given by dot product of del operator with vector f bar. Similarly, curl of a vector field f bar is also defined using del operator, and instead of dot product we will consider cross product of del operator with f bar. So divergence is a dot product of del operator with f bar, and curl is a cross product of del operator with f bar, and this dot product is always going to be a scalar function, and we know that vector product is a vector function. So f bar is a vector field and divergence of bar is a scalar field, and curl of f bar is a vector field, and it is given by cross product of del operator with f bar. Suppose we are talking about vector field in R3, then we have three components denoted by f1, f2 and f3 in R3, and as I discussed, curl is nothing but cross product of operator del with this vector field f bar. So we know how to find out cross product or vector product of two vectors. First row is ijk, that is unit vectors in R3. Second row is components of del operator, which are partial derivatives with respect to x, y, z, because we are talking about curl in R3. So we have three components for del operator, and then last row is components of this given vector field, which we have denoted by f1, f2, f3. So this is the definition of curl of a vector field. So that I have written systematically. Let f bar equal to f1i plus f2j plus f3k be a differentiable vector function or vector field, then the curl of f bar is denoted by this notation curl f bar and is defined as cross product or vector product of del operator with f bar. So ijk, components of del, which are partial derivatives with respect to x, y, z, and components of given vector field f bar. We consider one question about curl of a vector field. This question was asked in GTU Winter 2019 exam. Here we are asked to find the curl of this vector field. So here we can see these are the components of given vector field x, y, z, 3x square y, x z square minus y square z. So we can directly start by the definition of curl. We can denote given vector field by f bar. So let f bar equal to given vector field, which is x, y, z times I plus 3x square y times j plus x times z square minus y square z times k. And by definition we are interested in the curl of this vector field f bar. So this is equal to vector product of del operator with f bar, and we can write the components here. Here I have to write down the determinant notation. Then first row is this three unit vectors I, j, k. Second row is partial derivatives with respect to x, y, and z, and then components of f bar. First component is x, y, z. Second component is 3x square y, and third one is x into z square minus y square into z. Now we have to simply expand or evaluate this determinant. So we consider this type of things plus minus plus. So I times determinant of this quantity. So partial derivative of x z square minus y square z with respect to y, and we will consider x and z as constant. So partial derivative of x z square with respect to y is 0, and partial derivative of minus y square z with respect to y is z constant, and derivative of y square is 2y, and this negative sign, minus partial derivative of this quantity with respect to z, and there is no z here, so partial derivative is 0. So we have only minus 2yz times I. Then we consider this minus j cap into determinant of this quantity. Okay, we consider in this way. With j we will have partial derivative of x z square minus y square z with respect to x. So first we write that derivative z square is constant, derivative of x is 1, and there is no x here, so derivative is 0. Similarly, partial derivative of this xyz with respect to z, so minus x into y is constant, derivative of z is 1. This is multiplied with j. So this finishes I into something and j into something, minus j into something. Now we consider product with last component, that is k bar into determinant of this 2 by 2 matrix. So for this k cap we will not consider this row and this column, and we have to write down determinant of this quantity. So partial derivative of 3x square y with respect to x, 3y is constant, derivative of x square is 2x, and 2 into 3 is 6, so we have 6 times x into y, minus partial derivative of xyz with respect to y, and it is x into z constant, derivative of y is 1 into k bar. So this is the curl of given vector field. So you can see it is easy to decide the curl of a vector field. You just have to decide the vector product of del operator with f bar, and here you must know how to evaluate determinant of order 3. So I into determinant of this quantity. Okay, let me recall again. First we have taken I into determinant of this quantity, then minus j into determinant of this quantity, and then k into determinant of this, and we have used the definition of partial derivatives. So this is simply the curl of given vector field. So you can remember this definition, and using this definition we can easily obtain curl of a given vector field simply by expanding this determinant. So this is all about this session. I hope you like it. Thanks for watching.